Hello everyone, I welcome you all to Startup Academy, your online gateway to success in ISS exam. We have been doing the topic systematic sampling, and we have covered simple random sampling with replacement, simple random sampling without replacement, stratified sampling, and now we are moving forward with systematic sampling. This is the third part of the video, and this topic comes under the descriptive paper 3 of statistics and is considered one of the most important paper or difficult paper. So we are covering first of all that we have completed econometrics, and now let us begin with further with systematic sampling. So in yesterday's lecture, we have done estimation and variance of systematic sampling. Now today, we will do one more relation or one more variance formula of systematic sampling. There are two. One is related to correlation coefficient, and the other one is related to within the sample variance. So correlation coefficient we did it yesterday. Now today we'll do another method. Variance of systematic sampling. This variance is basically used in comparison of two random sampling, which will be the further topic of this lecture video. So first of all, we will find this. So, what is variance of systematic random sampling? It is nothing but summation I 1 upon n, summation j goes from 1 to n, 1 1 upon k, summation I goes from 1 to k, y bar I dot minus capital Y bar whole square. This was the formula for variance of Y bar, simple random sampling, or we can say estimation reduces to this one. Now, what is the formula? Uh, what is the formula for y bar I and y bar square? We can rewrite y bar I and y bar square as 1 upon k, summation I goes from 1 to k, y bar I dot minus capital Y bar whole square. Here we can write this as estimation of this. Here, this can be denoted by this. Now, moving forward, we can write that uh, S square, that is the variance of simple random sampling without replacement, is nothing but 1 upon n minus 1. Summation I goes from 1 to k, summation j goes from 1 to n, yij minus y bar whole square. We know that this is the formula. So we can write it as n minus 1 into s square is nothing but summation I goes from 1 to k, summation j goes from 1 to n. Now we can add and subtract y bar I dot in this equation. This can be done. Now this summation, or instead of this, we can put the bracket here. Now opening this summation, we will get n minus 1 s square is nothing but summation I goes from 1 to k, summation j goes from 1 to n, y bar yij minus y bar I dot whole square plus summation I goes from 1 to k, summation j goes from 1 to n, y bar I dot minus capital Y bar whole square. This can be written. Now this is nothing but this formula. It is nothing but variance of simple. Okay, let me write it first. K into n minus 1 s w square, and this is here there is no jth term, so we can write it j the summation of j as n, and we are left with I goes from 1 to k, y bar I dot minus capital Y bar whole square. Now where SW square is nothing but 1 upon k into n minus 1, summation I goes from 1 to k, summation j goes from 1 to n my n, yij minus y I dot bar square. This is the variance among the units within the sample. Since we have taken, suppose the sample is S1, S2, S3 up till Sn. So the sample must be, all the variances are S1 square, S2 square up till Sn square. So these variances may differ within themselves, and this difference of variance is known as SW square, where W stands for within the sample. So this is it, and this is our formula. From this formula, we can say that summation I goes from 1 to k into n, y bar I dot minus capital Y bar whole square is nothing but n minus 1 into s square minus k into n minus 1 into sw square. This is the formula. Now taking n, small n, in the denominator of both of them, we will get summation I goes from 1 to k, y bar I dot minus capital Y bar whole square is nothing but n minus 1 upon small n s square minus k into small n minus 1 upon small n sw square. So this is our equation number 2, and this was our equation number 1. Putting equation number 2 and equation number 1 equal from equation 1 and 2, we get variance of y bar systematic is nothing but, now here the denominator is k, so we will put n minus 1 upon small n k s square minus k into small n minus 1 upon small n k s w square. Now we know that small n into k is nothing but capital N, so we can substitute that here. N minus 1 upon capital N into s square minus k into small n minus 1 upon capital N, or here we can just cancel the kth term, k with k, and we are left with small n minus 1 upon small n into sw square. which is known as the variance of y bar systematic. This is the second formula for variance of y bar systematic, and the first formula we did yesterday was variance of y bar systematic is nothing but capital N minus small n upon n s square 1 plus n minus 1 into rho, where rho is correlation coefficient. This is the second formula or the first formula. Okay, now we start with comparison. We will first compare simple random sampling with simple random sampling without replacement with systematic, then stratified with systematic. Then we'll compare all three of them using the linear formula, which we'll be doing in the next class. So today we'll do comparison between simple random sampling, comparison between simple random sampling without replacement and systematic sampling. Now we know that variance of y bar without replacement is nothing but n minus n upon n into s square, and variance of y bar systematic is nothing but capital N minus 1 upon capital N into s square minus small n minus 1 upon small n into sw square. Now, variance of y bar without replacement minus variance of y bar systematic can be written as, here this variance can also be written as nk minus n upon capital N s square, which can be written as n k minus 1 upon capital N small n s square. Now here small n and n can be get cancelled, and this is nothing but k minus 1 upon capital N s square. So this is k minus 1 upon capital N s square minus capital N minus 1 upon capital N s square plus small n minus 1 upon small n sw square. Which can further be written as k minus 1 upon n minus n minus 1 upon n into s square plus n minus 1 upon small n into sw square. So this can be written as k minus 1 minus n plus 1 upon capital N into s square minus n minus plus n minus 1 upon n into sw square. So this will be 1 and 1 will get cancelled, and we are left with k minus capital N. Now k minus capital N can be written as k minus k small n upon k into n s square plus n minus 1 upon small n into sw square. So here taking the k common, 1 minus n upon small n into k, here k again it gets cancelled, s square plus n minus 1 upon n sw square. So we can write it as variance of y bar without replacement minus variance of y bar systematic is nothing but n minus 1 upon small n into sw square minus s square. Now checking the efficiency. So if SW square is greater than S square, if FW square is less than S square, and if SW square is equal to S square. So if it is greater than S square, then Y bar systematic variance of Y bar systematic is more efficient than variance of Y bar without replacement. See, if it is greater than 0, if it is greater than 1, then simultaneously Y bar WOR is greater than Y bar systematic, and the one whose variance is less is more efficient. Similarly, here variance of Y bar systematic is less efficient than variance of Y bar without replacement. And here both are equally efficient. So this is to check between the efficiencies of variance of simple random sample without replacement and systematic sample. Now we will check the relative efficiency. Relative efficiency of variance of systematic with respect to variance of Y bar without replacement. Now, whenever we check relative efficiency's formula is always when the one for whom we are checking will come in the denominator. So we are checking for systematic, so it will come in the denominator, Y bar systematic. And we are doing for without replacement, so without replacement, it will come in the numerator. So variance of Y bar without replacement is nothing but capital N minus small n upon N into S square, and variance of Y bar systematic is nothing but capital N minus small n upon N S square into 1 plus rho n minus 1. It is n minus 1. Here also it is n minus 1. This is the formula. So n and s square will get cancelled, and we are left with capital N minus small n upon capital N minus 1. So here capital N minus small n can be rewritten as nk minus 1, and here it can be written as nk minus 1, right? And in the bracket we are left with 1 upon 1 plus rho n minus 1. So here if we put rho equals to 1, if we put rho equals to 1, we are left with 1 upon n gets cancelled, and here the relative efficiency is nothing but 1 upon nk minus 1 with a sign of minus in it. And if we put rho is equals to, and if we put rho is equals to 1 upon nk minus 1, we will get relative efficiency as 1. So rho lies between minus 1 upon nk minus 1 and 1. These are the limits of rho's. Now for checking the relative efficiency, if rho is less than minus 1 upon nk minus 1, rho is greater than minus 1 upon nk minus 1, and rho is equals to minus 1 upon nk minus 1. If rho is less than this, then variance of y bar systematic is more efficient than variance of y bar without replacement. If rho is greater than minus nk minus 1, then variance of y bar systematic is less efficient than variance of y bar without replacement. And here both are equally efficient. So this completes your comparison between simple random sampling without replacement and systematic sampling. I hope you got all that we have done in the class today. And keep on rewriting this because this is a difficult topic and this has been asked in the PYQs n number of times. And tomorrow we'll do comparison between stratified random sampling and systematic random sampling, and after that comparison among all three of them. So keep on working hard and with consistency. Keep on watching the videos and keep on doing it on your own at your home. All the best. Have a nice day. Thank you.